Assalamualaikum warahmatullahi wabarakatuh and a very good morning to our presentation panel, Mr. Mazlan bin Muhammad Mansur and also Mr. Luqman Hakim bin Hamzah. I'm from Faculty of Mechanical and Manufacturing Engineering Technology. I will present about my Project Sarjana Muda 1, which is PSM1. And my title of this project is Design and Testing of Prosthetic Legs. Okay, first of all, my name is Muhammad Iman Ashraf bin Muhammad Yazid. I'm from BMMA course, and my supervisor is Mr. Muhammad Rafi bin Omar. Okay, for the introduction, first, the limb prostheses have been invented in order to replace the loss of body part due to disease, accidents, warfare, and also natural imperfection, which is from the early life. Okay, next, the old limb prosthesis is made from wood, leather, and metal, which offer limitation in movement. This is because the material that has been found like in today is not been found on the old day. Okay, so if we want to compare with the new invention, the prosthesis has become more functional and also comfortable to use for the user. Okay, for the objective, the main purpose of this project is to propose the effective methodology in creating a prosthetic legs. So, the first objective is to verify and learn the best method of data gathering based on actual leg. Next, to design and optimize based on actual leg measurement to achieve patient's comfort. Next, to able run the strength analysis on prosthetic leg using simulation through CATIA V5 and also Altair HyperWorks. And lastly, to study and improving the existing characteristic of prosthetic leg. Okay, for the scope of project, we will design the prosthetic leg based on the patient's actual leg. Next, CATIA software is used as a medium to design the prosthetic leg. 3D printer is used to create the actual prosthetic leg. Learning the reverse engineering software of CATIA and testing equipment. Okay. For the problem statement, there are several problem statements that are included in this project, which is the material selection in order to produce the product uh, with the weight reduction will be important because it will determine the comfort towards the patient. Next, difficulty in getting accurate data by using 3D scanner based on the actual leg will be cause the trouble in gathering the data. And lastly, some of the product existed in the market is not really fitted with the patient's residual limb. So this indirectly uh, will lead to discomfort for the patients. Okay, for the literature review, okay, Alan J. Thurston state in his journal from 2007 that an even older examples comes from the 5th Egyptian dynasty, which from 2750 until 2625, which archaeologists discovered to be the earliest known spleen of that time. Okay, the examples refer to the prosthesis itself. Okay, next, he also says that pare was an innovator, which always able to seek a new ways of doing things. He favored message and designed a number of artificial limbs and artificial eye. Okay, Ambroise Paré is one of the innovator of artificial limb. He he is working in military as a military surgeon. Okay, and lastly, uh, Alan state that Marquez was fitted with a prosthetic leg which James Pott of London designed in 1800. It consists uh, it consists of a wooden shank and socket, a steel knee joint, and an articulated foot operated from the knee to the ankle by catgut tendons, and it became known as the Anglesey leg. Okay, Marquez is a soldier that served the military. For the methodology, okay, okay, the figure show the methodology flowchart. Okay, as we can see, we start from the feasibility study, and then we gather the data, which is the input of this project, and then we go to the mechanical design process. After that, we go to the criteria design, and after the criteria design, we go to the characteristic for material selection, and we go to the final product criteria selection. So if the final product criteria selection is not so suitable, so we will go back to the characteristic for material selection, and then we will go through the final product criteria selection again. Then after that, we'll go to the product design process. Next, we go to the simulation and test. If it's run well and give the better result, we will proceed to the strength analysis observation process. And lastly, we will go to the actual test. So where we test it on the patient. For the data gathering, we will use 3D laser scanning. First of all, we will use a plaster of Paris to craft the patient's leg. Let's say if the patient have one leg left, we will craft their other legs in order to get the same size and measurement of their legs. Okay, after that, we will scan the crafted legs and transfer the data into the CATIA V5 software. Okay, the advantage of using this method is the data that we will get is more accurate. Okay, this is because in the previous project we have used the 3D scanner in order to scan the living living part. It is hard because there are movement created. Okay, so in this case, if we use the craft leg, there are no movement. There are no movement from the object instead of the laser scanning itself. So the data that we will get will be more accurate, and it is also easy to transfer the data into the design software. Uh, in example for Katia and Altair Hyperworks. So next, we'll go into the mechanical design. Okay, in this project, we will use CATIA B5 and Altair HyperWorks as a medium. Next, there are four parts that involved in this prosthetic leg. Okay, first, the interface. Okay, the interface is the remaining limb that have connection with the prosthesis. So it's like a socks for the remain limb. It can be made from the soft or hard materials. An example of the materials, we use urethane liners, thermogel, and also silicone liners. So the example in the picture, we use the hard material. So okay, next, the socket. Okay, the socket is the connection between the prosthesis and the residual limb. After we use the interface, we have to use the socket that is made from mostly made from plastic, which is polypropylene. Uh, the socket must be intimate enough in order to determine the comfort for the patients. Okay, next we go to the pylon. Pylon, there are two types of pylon, which is exoskeleton and also endoskeleton. Okay, from the picture on the right, this is the example of the exoskeleton pylon, where it is the most common use in the market. It is also made from aluminium and titanium and material, more other material. Sorry. Okay, and lastly, for the foot, there are two basic types of prosthetic foot. First, on the left side is a solid ankle cushioned heel, and also for the right is elastic heel. Okay, the advantage of this foot is it is simple, inexpensive, durable, and low cost of maintenance. Okay, next. Okay, for the material selection, there will be several criteria that will be considered in this project, which is the durability of the material, the weight of the material, the appearance, and also the cost. Okay, the final product criteria. Okay, after we study about the material selection, the characteristic of the material selection, we have come with the final decision, which is the low cost of material and fabrication will be used in this project. The mechanism must be easy to function. The product must be able to accommodate the patient's load, where it has to be strong enough to hold the patient's weight. And lastly, the product must be light in weight. This will determine the comfort for the patients. Okay, for the product fabrication. Okay, we will use SLS 3D printer. SLS stands for selective laser sintering, where it is using the nylon powder. Okay, for the final product test, after the fabrication process, we will test the product on the patient, where the result might that produce might be slightly different from the analysis that has been made. This is because some of the several factor, which is like surrounding the surface of the floor and so on. And lastly, we jump into the conclusion. Okay, for the conclusion that have been made, it can be concluded that producing the prosthesis is a must. This is because we can get back the amputees, amputation victims uh, confidence level, where some of them will feel lost because it is hard to accept that we have loss of our limb. So with this project, students are able to discover the new method of data gathering by using POP or plaster of Paris. The student also will be able to design and optimize the prosthetic based on the patient actual leg measuring. By using CATIA V5 and Alter Hyperworks, students also will be able to run the strength analysis towards the design that has been created. So, and then this will provide the result where it can be as evidence to convince the patient about the product, and indirectly the data also can be used as an improvement if there is any deficiency occur. And lastly, the students are able to study and improve the prosthetic based on the deficiency of existing prosthetic leg in the market. Okay, thank you.